So you might be watching this video for a couple reasons. One might be because you learned about SOHCAHTOA in class and you have no idea what's going on and you want some help. Another reason might be as you're interested in it, you've never really heard of it, but you want to see what's going on. And the last reason might be that you saw this really weird looking title for this video and you have no idea what it's talking about. So whatever your reason is for watching this video, I'm going to go over what SOHCAHTOA is, and it's probably I'd say the single most important thing you'll learn in high school math in terms of how elementary but applicable this kind of process is of finding different ratios, and we'll go over it right now. So stay focused, this is a super important concept. So SOHCAHTOA, what the heck does that mean? Well, it's all off the basis of triangles. Okay, so let's say we have a triangle here. Let's say that the lengths of the triangle are 4 units, 3 units, and 5 units here. And this is a right angle. Okay, it's important to note SOHCAHTOA the only case it works is if we have a right triangle. So if a part of our triangle is perpendicular, two legs are perpendicular to each other. And in this case, they are, because I indicated here with kind of that half a box looking shape that it's a right angle there. So SOHCAHTOA, first let's focus on the SO. Okay, we're not going to worry about the CAHTOA yet, but it's all kind of the same idea. So SO means that the sine of an angle is equal to the opposite over the hypotenuse. Okay, what the heck does that mean? Okay, well, let's say we have an angle we're looking at here. We're trying to figure out what this angle is. Okay, so the sine, and on your calculator, it's just going to be SIN instead of SINE. It's just kind of the shorthand we use. The sine of theta, our angle, so the sine of our angle theta is going to be equal, that's where this OH comes from, the opposite over the hypotenuse. Okay, the opposite over the hypotenuse. So what does opposite and hypotenuse even mean? Well, I said it in a previous video, the hypotenuse is always the longest side of a right triangle. So it's always the side that's opposing, it's kind of opposite to the 90 degrees. So if we go to the 90 degrees and we go straight out in between the two legs, we're going to hit the hypotenuse. It's always the longest side. So the sine of our angle, theta, is going to be whatever the opposite is over the hypotenuse, which we know is 5 now, right? The longest side. The opposite is just, if we go to our angle theta, and if we kind of go straight out, we radiate from that point, whatever side we hit, that's the opposite. So I talked about, like, when I was talking about acute angles, I kind of described them as an alligator munching. So if we kind of drew teeth in here, and this was our angle right in here, this is kind of like if you imagine a stick that the alligator's chewing on. That's 3 meters or 3 centimeters, whatever long. This is what the alligator's chewing. Okay, so the angle is kind of the angle between its jaws, and if you go straight out, that's the opposite side. That's the side that the alligator's chewing. Okay, if you wanted to find the opposite side of this, say this angle here was x, the opposite of this, well, now the teeth would be going here. Its jaws would be here now, and it would be chewing on this 4 centimeter or 4 meter long stick. Okay, so maybe that analogy made no sense to you, but basically, the opposite side is just starting from your angle and going straight out until you hit another side. So the opposite in this case is going to be 3 over 5. So to find this angle, we go into our calculator and we click the second function. So it's usually like a blue button in the top left of your calculator. Depends on the calculator, but you go the inverse sine. So it's going to be the same sine, but except it has this -1 here. Okay. And this is going to be sine of the inverse sine of 3 over 5. So this is going to give you your angle. If you know the sine of your angle is 3 over 5, to find the angle that's on the left side, we take the inverse sine. So we move this over and take the inverse sine, and that's going to move the angle over to the right to give us our angle. So if I go into my calculator, make sure I'm in degree mode, I take the inverse sine of 3 over 5, and I get 36.9. So that means for a triangle with an opposite of 3 and a hypotenuse of 5, this angle is going to be 36.9. But wait, SOHCAHTOA has 3 different terms, and we only use the SO. So could we do the same thing with the CA and the TOA? Absolutely. Let's say sine didn't exist. We have no idea what sine means. How could we figure out the angle theta using CA and TOA? Well, luckily, it's all kind of the same idea. So sine was opposite over hypotenuse. That's where the OH comes from. Now, CA is adjacent over hypotenuse. So the cosine, this is how you say it, cosine. It's like sine with a co in front of it. And the shorthand is just COS, cos. So cosine of theta, our angle, is equal to the adjacent over the hypotenuse. That's where the AH comes from. So CAH, CA. Okay, adjacent. If you ever heard of adjacent, like they use a lot in first aid. Like if you cut yourself, they call it, or it's, okay, honestly, it's not super important, but um, it's basically like the side that's hugging the angle with the hypotenuse. So if this is the hypotenuse, your adjacent side is kind of the side like laying next to it. So opposite's kind of like the furthest side length away. Adjacent, it's not the hypotenuse, it's not this 5, but it's the 4 that's right next to it. Okay, so this is going to be 4, and this is going to be over h, which is still 5. Another way you can think about the adjacent is if you had your alligator teeth. I know some of you might like this, some of you might think it's the most annoying analogy ever. But if this was your alligator jaws, the hypotenuse would be the longer jaw, and the adjacent would be the shorter one. The opposite would be what you're chewing. So the longer jaw, the top of your jaw, would be the hypotenuse. The bottom of your jaw, the shorter one, would be 4, which would be the adjacent. And the opposite is what you're chewing, what the alligator's chewing. So that's going to be 3. Okay, so if we want to find theta, we would go, last time we did the inverse sine of 3 over 5. This time we're going to do the inverse cosine of 4 over 5. And it just so happens that that is also 36.9. So we can find the same thing using cosine instead of sine. Now, how about the TOA? Well, the TOA, you guessed it, we've already used O, A, and H. We've used all of them. But, so this was 5, this was 3, this was 4. The TOA, so this is called tangent. And the shorthand we use for tangent is just tan. So tan of theta, tan of our angle, is the opposite over the adjacent. Okay, so the opposite over the adjacent, that's going to be the opposite, right? What the alligator's chewing, the 3, over the A, the adjacent, which is 4, the shorter jaw. So tan theta is 3 over 4. So if we want the angle theta, theta is going to be the inverse tan of 3 over 4. And I have a feeling, yep, this is also 36.9 degrees. So you can use all 3 of these to get the same thing, except it's good to have all 3 of them in your back pocket because typically you're only going to be able to use one of them. So let's say you didn't know that this opposite side length was 3. Now you're limited to what you can do. Because before we had a lot of freedom. We knew that every side length was a certain number, 3, 4, or 5. In this case, we only know the 4 and the 5. So we only know the adjacent and the hypotenuse. So previously, before you knew what SOHCAHTOA was, you might say, well, I don't even need this, right? I can use Pythagoras. I can say a squared plus b squared equals c squared. So you'd say, okay, well, I could call a 4. So 4 squared plus, if this was b plus b squared, that's going to be 5 squared. I could subtract them, so this would be 25 minus 16. So b squared is 9, square root that, b is going to be 3. But you have to do all this, and for what? Just to figure out that this is 3? Unless the question's asking you, you don't even need to know what this is to figure out what theta is. Because with SOHCAHTOA, if you know the adjacent side and you know the hypotenuse side, right? If you know this side right here to be 4, you know this side here to be 5, you can just use the cosine function. So the cosine of theta is the a over h, which is 4 over 5. And you can use this. Maybe you didn't know this was 5, maybe you knew this was 3. Well, this is the opposite, this is the adjacent. And by the way, if you're confused, adjacent is spelled like this. Adjacent. The adjacent side is 4. Well, which of these three uses O and A, opposite and adjacent? Well, TOA. So the tan of our angle is going to be O over A, which is 3 over 4. So the inverse tan of 3 over 4 is going to give us our angle theta. So that's really what SOHCAHTOA is doing. And when you put in your calculator, for example, let's say we did the sine of, I don't know, 30. Okay, the sine of 30 degrees, so the sine, I'm going to write it here, the sine of 30 degrees equals 0.5. And actually, I'll write that as a fraction. I'll write that as 1/2. What does that even mean? Well, that just means if we have some triangle, and remember, it has to be a right triangle. It has to be a right triangle. If we had, this is 30 degrees, this is 90 degrees, this would have to be 60 degrees, but that doesn't really matter. We're looking at the 30. Remember, sine with SOHCAHTOA is the opposite over the hypotenuse. So no matter what these lengths are on the side, the ratio between the opposite side and the hypotenuse side is always going to be 1 to 2. So a question might be, you know this angle is 30 degrees, and you know that this is 2 units, right? What's the length of the hypotenuse? Well, the ratio between 30 degrees and the opposite and the hypotenuse, these are always going to be 1 to 2, or 2 to 1, depending on how you think of it. So if the opposite side is 2, that means if we want to make this 1 over 2, this hypotenuse would have to be 4, because this simplifies to 1 over 2. So if this angle here was 30 degrees, this was 2, and this was 4, our ratio would still hold true. So let's do a practice problem without like such perfect numbers. Let's say we're looking at the triangle, and this is a right triangle. Remember, we can't do these, okay, that was terrible. We can't do these problems if they're not right triangles. That's a big deal. So, indicate it's a right triangle here. This is going to be 15 units. This is going to be 13 units. And I want to know what this angle is. That's all I'm giving you. I'm giving you one side length, another side length, and I'm indicating what I want you to find the angle to be. So first of all, we have to look at where our angle is and say, okay, what pieces of information do we know? Well, we don't know what this side is. So we're going to ignore that. That's the hypotenuse. That's the longest side of the triangle. We're going to ignore that. We don't know what that is. We know that 15 is here. And if we imagine these teeth here, where the angle is separating the teeth, and we go straight out, what the alligator is chewing is going to be the opposite side. So we know the opposite side is 15. Okay, well, if we know the opposite's involved, then we're not going to be looking at the calf, because these are the only two with opposite in them. Now we have to decide if we're using the hypotenuse or the adjacent. Well, remember, the adjacent between the hypotenuse and the adjacent is the shorter one. The hypotenuse is always opposite to the 90 degrees. The adjacent, it's always on the other side. It's laying on the other side. So this 13 here, it's going to be adjacent to our angle. So that means we're not going to use SO because we don't know the hypotenuse. We don't know the H. We're going to be using TOA. So the tangent of our angle is going to be the opposite, which is 15, what the alligator is chewing, divided by the adjacent side, which is 13. And actually, if we want to find the angle theta, right? But before we even do this, let's guess what this is. Let's guess what the angle theta is. So it's going to be somewhere between 0 and 90. It looks like it's going to be around 45. I'm going to guess maybe about 48, 50 degrees. That would be my guess. So anytime you do these questions, always kind of make a guess ahead of time in your mind. And if it's something that's way off, maybe try and do that again, because sometimes you might get an angle like 300. And if you get 300 degrees for a question like this, you know you went wrong somewhere. Or even like 80. 80 degrees would be like somewhere over here. This would be more like 80 degrees. So if you get a number like 80 for this one, you're going to want to look over it. So theta, if we know tan theta is 15 over 13, theta is going to be the inverse tan of 15 over 13. And I'll just go to my calculator here. The inverse tan of 15 over 13, that's going to be 49.1 degrees. Let's just round here to 49 degrees. And that's about what I said, right? That was about 48 to 50 degrees. And that sounds right. So if we imagine 49 degrees going in, kind of plopping in there, that's going to be our answer. Okay, let's go the other way. Let's say we already know our angle. Let's say we're trying to use that to solve a side length. So let's say that this was, let's say this was a, yeah, I'm gonna make this into like a word problem on the spot. Let's see if I can do it. Okay, I'm gonna draw a tree. Wish me luck. Okay, this is my amazing tree, and it's gonna be kind of going up like this. I know, try and hold the applause. Okay, this is my tree. Okay, so this tree, it's gonna be, let's say it's 50 meters high. Okay, let's say that the person looking at the very top of the tree, let's say there was a nest in the tree, they had to look up at an angle of 23 degrees. Okay, maybe the question's saying how far away is the person standing from the base of the tree? So if this was the person here, they're looking up at an angle of 23 degrees to see the top of the tree, which is 50 meters off the ground. We're looking for how far away this person must be. And just from knowing those two things, we can figure out how far the person must be standing. So let's call this x. Okay, so let's look at what we have and what we don't have. We don't have the hypotenuse of this triangle. We don't have this angle, and we know that this is 90 degrees because it's perpendicular. Okay, so we want our equation to have this 23 in it, this 50 in it, and this variable x in it, because x is what we're solving for, so x needs to be in our equation. So our angle theta is 23 degrees. I'll write that here. This 50, let's think, is that going to be opposite or adjacent? Well, if this was an alligator, it always chews the opposite side. So if it's chewing on the tree right now, the tree, the opposite side must be 50. So O equals 50. And this x is going to be our adjacent side. So our adjacent side is x. So we know we're dealing with O and A. That means we must be using the tangent function. Okay, so the tangent function, we're going to be doing tangent of our angle, which is 23 degrees. This is going to be the opposite, which is 50. We just found that out, over x. Okay. Now x is on the bottom of our fraction right now. Let's multiply both sides by x. So the left side is x times tan x, or sorry, x times tan 23, and the x cancels on the right, so we're just going to get 50. But we still just want x to be solved for. We don't want x tan 23. So right now the x and the tan 23, they're multiplying into each other. We don't want the tan 23 to be there, so if they're multiplying and we want to undo that multiplication, we're going to do the opposite of multiplying and divide by tan 23. Because if we have x, we multiply by tan 23 and divide that by tan 23, the tan 23s are going to go away, and we're just going to get x on the left. So this x here, the distance from the person to the base of the tree, is going to be 50, the height of the tree, divided by the tangent of the angle of inclination. So 50 over the tangent of 23. And before we do this, let's kind of make a guess in our head. Okay, I'm going to guess this is about maybe 125 units. It's going to be over 100, I think. Okay, so I'm gonna say about 125, maybe 100, I don't know. Let's do it here. So 50 over tan 23. Yeah, so this is 118 about. This is about 118 units. So 118, I think I said meters. Okay, so this, instead of x, we're going to write 118. And that sounds about right. So it's a bit over double of the height of the tree, which looks good. Okay, and maybe I didn't want you to find the distance from the base of the tree to the person. Maybe I wanted you to find, let's say this person was throwing a rope to the top of the tree. How long would the rope have to be if they threw the rope at an angle of 23 degrees above the ground? Well, that means that the rope right here is represented by this hypotenuse. So we're going to call this x. We're going to imagine kind of this is a rope going along, kind of grappling to hit the top of the tree. Okay, so this is the x now. So now we're dealing with the hypotenuse on the opposite side instead of the opposite and the adjacent side. So we have to ask ourselves, we have our angle, which trig function uses opposite and hypotenuse? Well, opposite and hypotenuse is going to be the sine function. So the sine of our angle, 23 degrees, is going to be equal to the opposite, 50, divided by the x. Okay, so like I did last time, we're going to multiply both sides by x, so it's x sine 23, right? And that's going to be equal to 50. And then we're going to divide both sides by sine 23. Last time it was tan 23, this time it's sine 23. So sine, tangent, and cosine, they do make a difference in your answer. 50 divided by sine 23 is going to be 128. So remember last time we got, what was it, 118? This time it's 128 because the hypotenuse length is going to be longer than the adjacent length. The hypotenuse is always the longest side. Okay, let's do the last kind of variation. Let's say I told you this rope length was 150 meters. What's the height of the tree? Okay, let's figure that out. So the rope length, when it's 23 degrees above the ground, what's the height of the tree if it's 150 meters in rope length? Well, we're dealing with opposite now and hypotenuse. So the opposite side, we're still going to be using sine because it's still opposite and hypotenuse, except we're going to solve it a bit different now. So the sine of 23 degrees is going to be x, our opposite, over 150, our hypotenuse. So now it's a bit easier because now we can just multiply by 150 on both sides. The 150s are going to cancel, so x is going to be 150 times sine 23. And before we calculate it, let's just make a guess to make sure we're about right. This looks like it's going to be maybe 60 meters high. Maybe about, just over a third. Just under a third of this total hypotenuse length. Not completely sure, but if it's between 50 and 70, I think we'll be good. So 50 times sine 23. Yeah, so this is going to be 59. 59 meters. That looks about right to me. Okay, and we could also use the cosine function. Maybe we knew that the rope length was 150. Maybe we wanted to find the distance from the person to the base of the tree, like we did in the last time. But now we know the hypotenuse of this triangle. So this will be the cosine, right, because we're dealing with A and H of 23 degrees to be X, our adjacent, over 150, our hypotenuse. Because remember, the cosine of an angle, is the adjacent side over the hypotenuse side. Okay, so if we multiply both sides by 150, that means 150 cosine 23, so 150 times the cosine of 23, that's going to be 138 to be equal to our x. And you'll notice that last time in this situation, we got 59. It was actually 58.6 to be exact. So this was 58.6, and this x here, this x was 138.1. So we can use Pythagoras to make sure we're doing this right. Since this is a right triangle and we know all three sides, we can kind of verify this. So a squared plus b squared equals c squared. A squared is a can just be 58.6 squared plus b squared, 138.1 squared. So it's just the two side lengths. That should equal the hypotenuse length, 150, right? The length of the rope squared. So 138.1 squared is 19,064, and we're going to be adding 58.61, right? 58.61. I'll do more exact values just to make sure it's as close as we can get. We're squaring that. So that's going to be 22,500. Should be 150 squared. Let's just make sure. Let's square 150 in our calculators. Yep, 22,500 does equal 22,500. So we can use the sine, cosine, and tangent functions to replace Pythagoras, which is pretty profound. We just kind of proved it right here. So this is what SOHCAHTOA is all about. Like I said, it's fundamental for trigonometry and tons of math. Sine, cosine, tangent, these different functions called cotangent, cosecant, secant, all these crazy things. This is the basis of all of that. So if you have an understanding of this, you'll be good. Trust me, okay? Thanks for listening, and as always, I'll see you in my next video.